For the double variable function f of xy equal to defined by this structure and asked about partial derivative with respect to x and y and function differentiability over the domain. So we have to check partial derivative and differentiability of the function over the domain. So first we are going to check partial derivative of this function. Is partial derivative exist or not? As function is given, so we can find partial derivative as suppose this is a function of variable u and v, then we can find partial derivative with respect to x and y of v u over v equal to u d over dx u, sorry, this is v u minus u, and this is derivative of v with respect to x. Using this formula we can find differentiability of cosine function. So partial derivative of f with respect to x, because of function is defined by x cube minus y cube upon x square plus y square. This is a constant function. So partial derivative can be easily find out using this formula. So it will be x square plus y square, and the derivative of numerator with respect to x will be 3x square minus of x cube minus y cube, and derivative of denominator with respect to x divided by x square plus y square raised to the power 2. As you can see, this denominator x square plus y square is defined for all when xy is not equal to 0 0. Means partial derivative exists whenever xy is not equal to 0 0. Now similarly we can say that partial derivative with respect to y, similarly partial derivative of f with respect to y exists for xy not equal to 0 0. So we need to check partial derivative at 0 0 only now. So we are going to check partial derivative at 0 0. For this, partial derivative of f with respect to x can be written as in terms of limit. This is at 0 0. So limit h tends to 0 f of h comma 0, or you can write 0 plus h comma 0 minus of f of 0 0 divided by h, and this limit will be h tends to 0. Because of h is tending to 0 not equal to 0, so function will be x cube, put x cube upon y cube divided by, this is plus or minus, this was minus, so minus x square plus y square. Structure of the function is this, so put h and k in this, it will be h cube upon h square, also this h will come to here, so this is h cube upon h, and this one equal to 1, because of this one is cancelled out from this one, and limit of constant function will be 1. Now partial derivative of f with respect to y at 0 0 can be find out in terms of limit k tends to 0 f of 0 comma 0 plus k, or directly I can write k minus of f 0 0 divided by k. Because of we know that function at 0 0 is 0, so there is no importance in evaluating limit of this expression. So limit k tends to 0 f of 0 comma k will be minus of k cube upon k square, and this k will comes here, so it will be minus 1. So we know that we evaluated partial limits at 0 0, hence partial derivative exists all over the domain. Now we need to check differentiability of the function over r square, over r square. So for this specifically I'm going to check differentiability at 0 0. But what is the procedure to say a function is differentiable at at a point ab? If function is differentiable at the point ab, I can write function as a linear expression f of a plus h comma b plus k minus of f of ab. Because of I am going to test a function at ab. If this one is equal to ah plus bk plus h phi plus k psi, and phi and psi are function of hk, when phi and psi, these two function is going to 0 0 whenever hk is going to 0 0. To check differentiability of the function at point 0 0, so it means that put a equal to 0 and b equal to 0. It means that f of hk minus of f of 0 0 is equal to, also I'm going to tell you what is this a and b used in this expression. A is equal to partial derivative of f with respect to x at 0 0, and b is partial derivative of f with respect to y at 0 0. So we know that this value is 1 and this value was minus 1. So put these values, so it will be h minus k plus h phi plus k into function psi. Because of f00 is 0, so f hk will be in terms of h or k, h cube minus k cube divided by h square plus k square, and this one is equal to h minus k plus h phi plus k psi. Now put h equal to r cos theta and k equal to r sin theta. Because of in two dimensional space we can consider it's in polar coordinates. Because of in polar coordinates we can easily check differentiability or continuity. So we are transforming this problem into polar coordinates, so we can easily justify the problem. So it will be r cube and cos cube theta minus sin cube theta divided by r square equal to h is r cos theta minus r sin theta plus r cos theta phi plus r sin theta psi. Take r common from right hand side, and this one will cancel out by this, and r remains here. And after taking r common from right hand side, this r will cancel out from this one. So left quantity or left terms we have cos cube theta minus sin cube theta is equal to cos theta minus sin theta plus r cos, not r, cos theta into phi plus sin theta into psi. Whenever this function phi and psi is going to 0 0, when hk, when h comma k is going to 0 0, it means that we need to send hk at 0 0. It means that r and theta we need to send at 0. It means that particularly fix theta, I'm going to fix theta and sending r to 0. Then this r comma theta will go to 0 0 from all direction. But particularly I am putting theta equal to 30 in single direction. First I'm going to approach theta equal to 30 and r going to 0. Then h comma k will go to 0, or I can write 0 0. H comma k goes to 0 0. It means this quantity, as I marked red, this and this quantity will go to 0 0. So left quantity we have cos cube theta minus sin cube theta equal to cos theta minus sin theta, and value of theta is 30. Now put this value. This value will become root 3 by 2 cube minus sin 30 is half, so half cube is equal to cos 30, and cos 30 is root 3 by 2 minus sin 30 is half. These two quantities in right hand side and left hand side are not same, so function is not differentiable. Function is not differentiable at 0 0 or origin. Because of function is not differentiable at 0 0, it means that function is not differentiable entire domain r square. So what we can conclude, partial derivative of f with respect to x and partial derivative of f with respect to y exist over r square, but function is not differentiable. So I can conclude from this problem, if function is not differentiable over the domain but partial derivative can exist over the domain, so which one option is correct? Both partial derivative exist and function f is not function is differentiable. This option is wrong. In option C, both partial derivative exist but f is not differentiable. This option will be right choice. And in these B and D options, one partial derivative is not exist. That's why both option will be wrong. So correct option is